Welcome back, everybody. We're diving deep today into something every database pro cares about, benchmarking. We're going to uncover common mistakes and misconceptions that can really mess up your results. We're assuming, relational databases already. Think of this deep dive as a checklist, because even experienced DBAs can fall into these traps.
Yeah, it's crazy how even little oversights can have a big impact.
Oh, absolutely. Imagine, right, you're presenting these amazing performance improvements, all proud and confident, and then boom, someone points out a tiny mistake that invalidates the whole thing. Not a fun situation.
No, not at all. Understanding these pitfalls is really crucial.
For sure. Okay, let's start with a big misconception. The idea that benchmarking tools are all you need. Like you install them, run them, and bam, you got your answers. What do you think about that?
Well, benchmarking tools are really powerful, no doubt. But they're not magic, It's like thinking a treadmill replaces a cardiologist. Sure, the treadmill stresses your heart, but you still need an expert to interpret the results, make a diagnosis.
That's a fantastic analogy. So the tool's the treadmill, it gives the workload, but it's human expertise that actually makes sense of the data.
Exactly. A tool might show you your database is struggling, but it won't tell you why. That's where a database expert steps in, someone who can analyze, find bottlenecks, and suggest how to optimize.
That makes a ton of sense.
Yeah.
You need someone who gets not just the database, but the hardware, the OS, how it all fits together.
Absolutely. Which brings us to another mistake people make, ignoring the I/O configuration. They focus on tuning the database itself, but the storage setup is critical for performance too.
I've heard that, but it's so easy to overlook. Can you give us some specific examples? What should we really be looking at?
Sure. Things like your SAN or NAS settings, your RAID levels, stripe sizes, even firmware on your storage controllers can have a huge impact. I've seen cases where just tweaking these settings led to 500% performance improvements.
500%. That's wild. So you got to treat storage optimization as seriously as we would tuning SQL queries.
Exactly. It's all part of the same puzzle,
Okay, let's move on to another misconception I've come across. The database objects designed by tools are automatically the best.
Yeah, that's a common trap. Tools can give you a decent start, but they often don't consider the specifics of your hardware, workload, or database system. To get truly realistic and efficient results, you need manual optimization.
So it's like having a race car, but with a minivan engine. The engine might be powerful, but without a streamlined design, you won't reach the car's full potential.
Haha, I like that analogy. You need both a good engine and a well-designed body to win. For databases, this means things like partitioning big tables, choosing the right indexing strategies, and the most efficient data structures. That's where a skilled DBA can really make a difference.
So don't just trust the tool blindly, right? Get in there and optimize that schema.
Definitely. Now let's talk about performance metrics. One myth is that transactions per second, or TPS, is the only metric that matters. What are your thoughts?
Well, I've seen people get obsessed with TPS, chasing those high numbers, but ignoring the bigger picture. I bet there's more to it than that.
Absolutely. TPS can be helpful, but it's not the whole story. You also need to consider the average response time, how long it takes for the database to complete each transaction.
So you could have a system doing a ton of transactions per second, but if each one takes forever, users are going to be frustrated.
It's like a highway jammed with cars, right? High TPS, but everyone's moving at a snail's pace. Still a bottleneck, even if it looks impressive on paper.
I see how focusing only on TPS can be misleading.
And that leads perfectly into our next point. Benchmarking is more than just running tests. It's a whole process, and it takes careful planning, execution, and analysis.
This is where things get interesting. So it's more than just hitting the go button.
Right. It's about defining your goals first, understanding your workload, meticulously setting up your test environment, then monitoring everything during the benchmark, analyzing the results, and refining your setup.
Wow, so it's a whole journey. It's like a science experiment. You form a hypothesis, test it, analyze data, and refine based on what you learn.
That's a great way to put it. Benchmarking is all about deeply understanding your database's performance. And that takes a systematic approach, asking the right questions, gathering data meticulously, and using that to make informed decisions.
So the key is, benchmarking isn't a set it and forget it task. It's ongoing learning, refining, always striving to improve performance. I think we're ready to dive deeper into that process now.
You're right. It definitely is. Benchmarking really is an ongoing journey. It's not just about the tests themselves. It's about understanding the why behind those numbers and using that knowledge to make the right choices.
So where do we even begin? We've talked about these misconceptions and the importance of having expertise, but what's a practical first step to make sure our benchmarking is effective?
Well, I think a great starting point is defining your goals. Like, what do you actually want to get out of this benchmark? Are you comparing different hardware, maybe seeing how a new software release impacts things, or trying to find bottlenecks in your system as it is?
That makes a lot of sense. Having a clear goal will help guide the whole process.
Exactly. Once you know what you're aiming for, the next step is understanding your workload. What are the usual queries and transactions your database handles? How often do they happen? And how much data are we talking about?
So we're talking about capturing how our database is actually used in the real world, right?
Precisely. That's where the idea of workload capture and replay comes in. It's a technique that lets you record real database activity and then replay it in a separate test environment.
Interesting. Can you tell me a bit more about how that works? Workload capture and replay, I mean.
Sure. Imagine you have a tool that can monitor your live database, recording every query, transaction, command, everything. It's like capturing the heartbeat of your database during a specific time with all the real-world complexity.
That sounds really useful. But how do we actually use this recording for benchmarking?
Well, once you've captured the workload, you replay it on a separate test system that's set up to mirror your production environment. So you're putting your test database under the same stress it faces in the real world, making your benchmark much more realistic.
It's like a time machine for your database, right?
Yeah.
You can replay the past and see how your system handles it.
Exactly. It's really powerful for testing different configurations or hardware. You see how those changes perform under real-world conditions.
So if I'm doing a big database upgrade or migration, workload capture and replay would be crucial to make sure it goes smoothly.
Absolutely. You can anticipate bottlenecks, fine-tune your settings, and avoid nasty surprises when you move to that new environment.
Okay, so we've set our goals, captured the workload, and got our test environment ready. What's next on this benchmarking journey?
Now it's time to carefully monitor the system during the benchmark. We need to watch things like CPU utilization, memory usage, disk I/O, and network traffic. Basically, anything that could indicate stress or bottlenecks.
So we're on the lookout for anything that might be impacting performance, right?
Exactly. And don't underestimate the importance of getting accurate, consistent measurements. Use reliable monitoring tools. Make sure your data collection is consistent across different test runs.
Sounds like we need to pay close attention to detail.
You do. Meticulous data collection is essential for getting results you can trust. If your measurements are inconsistent, you'll end up with wrong conclusions and a lot of wasted effort.
All right, so we've run our benchmarks, gathered all this data, and now we're looking at a mountain of numbers. What do we do with all this information?
Now the analysis begins. We need to dig through the data, find trends and patterns, and see how they connect to our goals and the changes we made during the benchmarking process.
Are there any tools or techniques that can help us make sense of this data?
Oh, there are plenty of tools and statistical methods we can use. Visualization tools can help spot trends and outliers, while statistical analysis gives us insights into whether our findings are significant.
So we're not just guessing based on what we see. We're using data to draw our conclusions.
Exactly. And remember, the goal of analysis isn't just a report. It's to get actionable insights to guide our optimization efforts.
Okay, it's all coming together now. Define goals, capture workload, monitor systems, analyze data, and use those insights to make decisions. It's a continuous improvement cycle.
You got it. And that brings us to the final stage, refinement and iteration.
So benchmarking isn't a one-time thing.
Definitely not. It's an ongoing process. We learn from our initial benchmarks and then make adjustments maybe to the systems themselves, the configuration, or even our benchmarking methods. And then we do it all again, new benchmarks, more data, and more analysis.
Like a constant search for better performance.
You could say that, but it's worth it. This iterative approach helps us keep our systems refined, adapt to new demands, and ensure our databases are always running at their best.
So we've covered a lot today. We've busted those misconceptions and outlined a structured approach to benchmarking. I think we've really gone deep into this topic. But before we wrap up, I want to go back to workload capture and replay. It sounds like a really powerful technique, and I'm curious about the practical side of things.
That's a great point. While it offers a lot of advantages, there are some practical considerations. Well, capturing a live workload can generate a massive amount of data. You need to think about storage, security, and how it might impact your production environment.
So it's not as simple as just recording everything. We need a plan for the capture process.
Right. And once you've captured that workload, your test environment needs to be able to replay it accurately. You might need to replicate your production hardware, software, even the network configuration.
I can see how that could get pretty complicated.
It can. But the benefits of realistic benchmarking often outweigh the challenges. And there are tools and techniques to help make it easier.
Okay, so workload capture and replay is powerful, but it needs careful planning and execution. What other practical advice would you give someone who's just starting with benchmarking?
Start small and iterate. Don't try to do everything at once. Pick a specific goal, focus on a smaller part of your workload, and gradually expand as you get more experience and confidence.
Don't bite off more than you can chew, right?
Exactly. And don't be afraid to experiment. Learn from your mistakes. Benchmarking is about discovery, and there will be bumps along the way.
So embrace the process, stay curious, and keep working towards better performance.
That's the spirit.
Well, I think we've covered a lot today, and I'm sure our listeners are ready to put all these insights to good use in their own benchmarking.
I hope so. And remember, benchmarking is a journey, not the destination. It's all about continuous learning and improvement to boost your database performance.
Thinking back to all those misconceptions, it's really clear that benchmarking is a lot more complex than it might seem at first glance.
Oh, yeah, definitely. It's not just about plugging in some numbers and getting an answer. It's about understanding what that answer actually means and how it fits into your goals and workload.
And realizing it's an ongoing thing, not a one-time event. Always evaluating, refining, adapting as our systems and needs change.
Exactly. The database world is always evolving, right? New technologies, new workloads, new challenges popping up all the time. Benchmarking strategies got to keep up.
So as we wrap up this deep dive, I want to give our listeners a few key takeaways. First, don't fall into that trap of relying only on tools. They're powerful, but they need human expertise to guide them.
For sure. A good DBA can analyze the results, find bottlenecks, suggest optimizations, stuff a tool alone would never catch.
Second, remember, benchmarking is a process with multiple steps. You define your goals, understand your workload, set up your testing environment carefully. And it's not over after you run the tests. You got to monitor the system, analyze all that data, and use what you learn to optimize.
And don't forget about iteration. Benchmarking isn't a one and done. It's about continually refining your systems, adapting, always looking for the best performance.
And last but not least, it's a journey, not the destination, right? It's about constant learning, always improving. Embrace the challenges, stay curious, and don't be scared to try new things.
Couldn't have said it better myself.
So there you have it, everyone. We busted some benchmarking myths, explored some cool techniques, and hopefully inspired you to look at benchmarking in a whole new light.
Remember, it's not just about the numbers. It's about understanding your systems, making them perform better, and ultimately making things better for your users.
Don't forget to like, share, and subscribe to The Deep Dive for more deep dives into all things data. Share your own benchmarking aha moments or challenges with us on social media. We love hearing from you. Until next time, happy benchmarking.